Whoops. Last week we talked about the LTM, and I said that there were questions about update messages, but to understand the update messages, we need to understand what makes up a table. So a table has two things. It has a set of column sources, and then it has an index. And an index is essentially a bitmap of valid long 64-bit numbers inside of those column sources. And every column source must have a valid, well-defined value for each of the bits that is set in the index. So the column sources are a map from name to column source, and those provide single element getters. Like there's one called get, which returns an object, and then there's others like get double, get float, get long, get int. So on any location, you can get the value of that column. So using these things together, we can do a lot of interesting stuff. So for example, if we just had a simple table with an index 0, 1, and 2, we can have column sources. Like we can have a column source for symbol and then another column source for price. So maybe we have Apple, VXX, and SPY for symbol, and 1, 2, and 3 for price. Now, when we do a where clause, we can keep those same exact column sources. And the reason we can keep those same exact column sources is we're keeping the structure and the data within the table exactly the same. We're just having a different set of valid rows in the table. So instead of having an index of 0, 1, and 2, you might have an index of just 1. So if you're looking at that table, then the derived table, then you only know that index 1 is valid, not index 0 and 2, so you shouldn't ask for those. On the other hand, we can also use an index with multiple tables. So let's say that instead of having 2 columns of symbol and price, we had symbol, bid, and ask. If we do an update statement, we have the same validity as the original table. So our index could be 0, 1, and 2, but we need to add a new column. So for example, we could say update equals bid plus ask divided by 2, and that gives you a mid price from a bid and an ask. So in that case, we would reuse our index. We would reuse the first 3 columns, and then we would add a column for mid. That's a column source. So it's also possible that you can start completely fresh. Like if you're doing an aggregation, then you might derive from one table, but you need completely different column sources, and you need completely different a completely different index, because the original table's index and column sources don't actually have very much to do with your result. And this can be mixed and matched. So for example, if you have a join, you might preserve the index of the left table and the left table's column sources, but then you would create brand new column sources. And if it's a natural join, you would create what's called a redirected column source for the right-hand side, where you wrap the right-hand side table column sources with basically a hash map or other lookup, so that you can derive a left-hand side index key to a right-hand side index key and make that transition. So given those two building blocks, the index and column sources, now we can start thinking about updates.
Okay, so before we do that, can we see if there are any questions?
Yeah, I actually have one. So I've come across in the Java docs quite a bit ArrayBacked column sources when using dynamic table writer. How are those different from a standard column source? Is it?
That's an implementation of a column source. So if you think about column source implementations, it's an interface, so it can do, it can be implemented however you want. The ArrayBacked column source works by having in-memory Java arrays that are divided into fixed sizes of 2K elements. So they always go from 0 to n minus 1 in terms of how many elements they have allocated. Not every element need necessarily be set, but you have to allocate all of them. There can't be any holes. And those are used a lot within the engine because it's fairly efficient to take an index, divide it by 2 to the 12th, mod it by 2 to the 12th, figure out which array something exists in, and pull an element out of the array. So I mentioned that there's get on a column source. Practically no high performance code should ever use get. It should, because these are virtual in their interfaces. There's also methods called get chunk and fill chunk, which will take an index, but really ordered keys, which index derives from, and give you values for many things at once. And that's important because the virtual function call overhead of having all these different column source implementations matters if you're doing it cell by cell instead of amortizing it. The other column sources that are kind of interesting are sparse array-backed column sources. Those use a multi-level page table design so that you can have holes in the middle of your column source. So, for example, you could have some values from 0 to, I think it uses 4K pages. So a few values, say from 0 to 100, and then you could have some more values at 2 to the 40 to 2 to the 40 plus 10, whatever it is. And you don't need to allocate all the values between 0 and 2 to the 40. I mentioned the redirected column source. So that maps what's called a redirection index, which is basically a hash table from long to long. And an inner column source. There's regioned column sources, which are going to represent on disk data. I expect Parquet still uses those, but I could be wrong about that. There are view or formula column sources, which will have a formula object, like in that bid plus ask, mid equals bid plus ask over 2. You could do that with an update, which creates an array-backed column source or a sparse array column source. Or if you did update view, that's going to create a formula column source, which maintains the formula. It maintains references to the original column source's bid and ask, and it will compute values on demand when you try and fill a chunk. And then there's, odd assorted things, but those are the biggest ones.
Right. Any more questions before we plow ahead? All right, Charles. One thing, can you before going, can you comment on indirection and performance?
So you can fill from many column sources unordered, and it's pretty okay. Like if you have an ArrayBacked column source, sure, filling in order is faster than jumping all over memory, but it's not earth-shatteringly different necessarily. On the other hand, if you're doing that with a disk-backed, a region column source, if you're grabbing random crap from it all over, you're going to be less happy. And this is part of the reason that chunking is important. So if we're talking about like a redirected column source, so when you want to fill values, like let's say from the right side of a natural join or the result of a sort, there will be a redirection index that maps outer keys for your derived table to the inner keys. If the fill you're doing is on an in-memory column source, and your inner keys happen to need to be read in order 3, 2, 1, we'll read key 3, then we'll read 2, and we'll read 1, and we'll stick that in your result. On the other hand, if you're doing it from disk, what we'll do is we'll sort that so they're in ascending order, read key 1, 2, and 3, and then permute them, so that you're reading with increased locality. So this is a good motivator to use fill chunk or get chunk instead of using the individual get operations, because if you're doing the individual get operations, you can't take advantage of those kinds of optimizations. The other thing that matters is a lot of the time you'll be using the same columns over and over. No, not the same columns, but columns that have the same redirection over and over. Like if you're looking at a sorted table and then you wanted to do an aggregation on that table, the chunked version of this includes shared context, which is originally Corey described it as a magic bag that allows us to cache things between get chunk calls that are related or fill chunk calls that are related. So if you're reading both bid and ask and there's a redirection, if you use an operation that has been chunked and is using shared contexts, you'll only need to do those hash table lookups one time for each key. If, on the other hand, you were calling get over and over and over on each of the individual column sources, then you're going to do those lookups repeatedly, once for each column.
Mike, it sounds like you might have a question.
No, I'm good.
No, okay.
All right. So now that we've sort of defined what makes up a table, we can talk about what an update looks like. So there's an index, there's column sources, and the update contains information about the index and possibly about what column sources have been modified. So a Deephaven update or a Barrage update is going to contain an index of added rows, an index of removed rows, an index of modified rows. If there are modifications, then it will also contain a modified column set. And the modified column set says which columns that have values that may have been modified in the rows that have been marked modified. And then finally, there's going to be shifts. So why don't we talk about added first? So, in the original example, I said we had a table with index 0, 1, and 2, and then we had a where clause that was looking for VXX, and it found it at index 2. Now, if I have a source table, which is one of the roots of the DAG, it can say, here are some added rows. Maybe we add rows 6 and 7. And you'll notice that 0, 1, 2, and 6 and 7 are not contiguous. There's no rule that index keys are contiguous. They are a bitmap. And there's an operation called flatten that will force them to be contiguous with redirection. But let's say we add 6 and 7, and 6 has a value of VXX for symbol, and 7 has a value for spy. So we'll send an update message that has 6 and 7 in our added index. The removed and modified will be empty. Modified column set will be empty, and there's going to be no shifts. Now, the where operation has a listener. That listener knows, okay, rows 6 and 7 are added, and it's filtering on symbol, so it can read rows 6 and 7 from the symbol column source. It will compare them against the match that it's expecting. And at that point, the only row that would match is 6. So it would send another update that says row 6 is added, no removals, no modifications, no shifts. Using that same operation, we might remove rows 1 and 7, for example. And in that case, we'll see, oh, row 1 is something that was in our result. Row 7 wasn't, so we don't care about it. So I can just pass down that row 1 has been removed from a where, because if it's taken out of the upstream table, it's certainly taken out of the downstream table. Can you get me some ketchup? And in this case, we don't need to read any data because it's just been removed. Now, let's start off with this original table that just has 0, 1, and 2. If I have a row that's been modified, let's say 0 and 1 have been modified, there's also a modified column set. So we have a symbol and we have a price. If my modified column set contains only the price, then I know that it can't affect my filter on the symbol. So I don't need to read symbol. All I need to do is tell my downstream listener that, hey, row 2, which is in your output set, has been modified. Importantly, I should not be telling the downstream consumer anything about row 1 because row 1 is not part of my result. Right? So I can't tell you extra. I have to tell you exactly what is relevant to your table. So, and I should set a modified column set that's just the same as that upstream table saying, hey, price has been modified. So that way, if the downstream operation cares about symbol, but not price, it can ignore the update and not do any more. For for, let's say now we're going to modify the same row 0 and 1, but this time both symbol and price have been modified. So because I'm a where filter, that means, oh, the column I'm filtering on has changed. So I need to read the values as they exist right now to determine whether those results are still in. So let's say, the original table flipped the order. So now instead of being SPY, VXX, and Apple, it's VXX, SPY, and Apple. So I would have to send an update message saying add row 0, remove row 1. Because the row that used to be there has been taken away, and there's been another row that's been added. And I'll pause for a second to.
So in regards to like modifications, the always the one that goofs me up. Like if I have, I mean, in regards to source tables, all of our source tables really aren't modifications, right? They're just adds, at least in a classic append only structure, right?
Yes.
Okay, so that you're really modifications really just apply to the DAG as you're moving through the DAG. You have a table and there's a modification to a row, and really then the right thing is, from a human perspective, if I'm looking at a table, I can kind of think of it as a flattened table. It has 4 rows and 7 columns, and if the data in row 2 column 3 just changed, that is a modification. It's not like, oh, it's actually a new row somewhere in the background of this table that is then being assembled to look like the flattened table that I just described. It's really just, row 2 just changed, column 3 or whatever I said.
Yeah, that's what the modification is.
Okay.
So, and the modifications are limited to, there's a modified column set. So we can say, in some of these rows that have been marked modified, price has changed or bid or whatever it is. What we can't say is that, okay, row 2 has changed price and row 1 has changed symbol, right? That they're bitmaps that will light the whole thing up. So one of the things that the engine sometimes does now is it can tell you, all right, row 1 was removed and row 1 was added. And that means, every column in that row has changed, basically. But it's not related to the modified column set. So there is a difference there.
And really the benefit of all this is, as you're doing table operations through the DAG, we're keeping track of this. And when something changes, meaning new data comes in, or logic makes it, or user experiences make it that the downstream tables are changing, we're keeping track of all this data accounting and incrementally updating the table operations.
Yeah. So, we talked about where in terms of removes and modifications, and that only cares about what the value is now. Why don't we think of the same kind of table? Let's just have, in this case, SPY, VXX, and Apple, and let's apply an aggregation to those. So instead of having price, why don't we have volume? And we want to sum up the volume of those things. If we get a modification, then to update a sum, we need to not only know, well, what is the value now? we need to know what the value used to be, right? So if we had values in the past of 10, 20, and 30, but one of the rows is modified, then, and 30 went to 40, we need to know, all right, well, I need to back out the 30 and add in a 40. And to support that, column sources not only need to provide a get operation, they need to provide a get previous operation. And what get previous is defined to do is return the value in that cell as it existed at the beginning of this update cycle. So what that means is when we get this modification, we can look at the previous value, we can do something with that, and then we can get the current value and do something with that. So, in this sum example, we can subtract 30, add 40, and we'll incrementally compute that the sum should be 10 higher.
So is there a chunking equivalent of get previous?
There's get prev chunk.
Okay.
And again, that should be what's used all the time, not the individual cell calls for anything that cares about performance. Because previous values can actually cost more than current, or vice versa too, depending on what exactly the column source is up to. The same previous logic applies to removes. So, for example, I was talking about modifying the price, but let's say I removed a row, and I need to take that out of the sum, so I need to read the old value to determine what comes out of the sum. So we've talked about adds, we've talked about removes, we've talked about modifies. And then the last thing that's involved in a Deephaven update is a shift. So let's say I have a table and I've sorted it. So I'm going to have a table with A, B, and C, and I'm going to sort on that column. And I'll sort descending. So my result is CBA. So what that will do is create a redirection index, basically a hash map from our output indices, from our output indices to our input indices. And in this case, if our original indices were 0, 1, and 2, our output indices are going to be 2 to the 30th, 2 to the 30th plus 1, and 2 to the 30th plus 2. So 2 to the 30th is going to map to C, map to 2, 2 to the 30th plus 1 will map to 1, and 2 to the 30th plus 2 maps to 0. Let's say I insert a fourth row into that source table. Let's say I insert at row 3 aardvark. Aardvark exists between A and B. So I now have a problem because my output index is contiguous. It's 2 to the 30, 2 to the 30 plus 1, and 2 to the 30 plus 2. But I need to put it somewhere between 2 to the 30 plus 1 and 2 to the 30 plus 2, and there is no place to do that. So what I need to do is I need to move the data that was in my output of 2 to the 30 plus 2 somewhere else so that I have room to insert this new row. So what I'm going to do is I'm going to say shift 2 to the 30 plus 2 by 100. So that way I have room. And what my update will look like is a shift of 2 to the 30 plus 2, and you have ranges, but in this case there's only one row. Say I shift that upwards 100, and I'm going to add something at 2 to the 30 plus 50, which will then be redirected to row 3 of the original table. So as a downstream consumer, I see an added row, and I also see a shifted row. And if I'm a consumer like a where clause, I have to pass those shifts through. If on the other hand, I'm an aggregation, I just ignore the shift, because a shift is not going to change data by itself. It can be combined with a modification, but by itself doesn't change any data. So moving that data won't affect my sum. But the addition will, so then I'll process that. And that's effectively all there is to an update with, some small examples.
Okay, so if we look at a case like sort, and let's say you're listening to the output of that, what do the changes look like? Is everything modified when stuff ticks, or are we doing something special with the reindexing or not?
So you said when stuff ticks. So any row that exists in the source and is added is going to be added in the result. Anything that's removed in the source is going to be removed in the result. Anything that's modified must also be modified in the result. And I say it must be modified in the result, but that doesn't necessarily mean it's a modification in a sort, because a shift is not allowed to reorder data. It's only allowed to move data up or down within the existing order. So if I invert 2 rows in my sort based on whatever the sort key was, that shows up as an add and a remove. Shifts are only going to be generated for the sort if it internally needs space. So a sort itself, it has to process shifts to keep its redirections consistent. But if a sort receives only shifts, it may not have any output. It could be like, all right, everything's the same. I'm good. I don't need to tell you anything.
But in a classic example, if I have a price feed and then I have a last by table on that price feed, and then I have a table that's a sort descending on timestamp of the last by of the price feed.
Yep.
Arguably at each micro batching frequency, if let's just say the world's moving like crazy, that last table is a brand new table each time, arguably, because whatever. It's resorted on timestamp, and let's just say it's a micro batching frequency of a second, just for the second. Then every stock ticked in the last second, and its timestamp is sort of randomly distributed within that second.
Yeah, you're going to have a lot of adds and removes.
So it's
and maybe some modifications.
It'll randomly, but that would be pretty crazy. Those ones, right? Okay.
And that's why we tell users to do their sort only if they need to, and not before other operations. If those other operations don't need the sorted output.
All right. What other questions on update?
So is a root table or a source table, is that append only?
It can be anything. Practically, what you guys will see are, so you probably won't see any append only source tables from disk because you don't have a data import server. Timetables are a source table. Those happen to be append only. Kafka tables are a form of stream table. Those are not append only, but you will see every row added that's new and every old row removed. You can, so one of our customers has a source table that does produce modifications. They have a price feed that turns into an in-memory table, excuse me, and you can have additions, removals, modifications. The classic append-only table is additions only when it's ingested into Deephaven, but that's not as relevant a use case for community.
So if a source table is not append only and you remove a row from a source table, does that, since that's the source table, are you just losing the reference to that data? Like what's happening there when something
it depends on whatever that table wants to do. Right? You're not allowed to look at removed rows except in the case of previous values. And those previous values only survive till the end of the cycle. So to meet the contract, that source table must hold on to those previous values until the cycle is over. But after that, it can do anything it wants with them. And you're not allowed to look at them. You don't know that they exist.
Sure. So does it free that memory when it's done with them if it wants to? Or
it is allowed to do anything. It's allowed to free the memory. It's allowed to hold on to it forever, and that's maybe not the best idea, but it could return it to a pool. It could say, you know what? I'm likely to add another row, and I'll just use that memory later. Because a lot of the time you can't actually free the memory, right? If you've removed a row that's in the middle of an array, for example, you just take it out of your bitmap, and if it's a primitive, you leave it there. If it's an object, you probably null it out so that you hold the cell in the array, but you're not going to waste resources on the actual object that's been removed forever. Or, maybe it's the case that the column source doesn't actually need any resources for that row. So, it's totally up to the implementer of the source table as long as they follow the contract.
Okay.
Right. Any other questions? Charles, what should we have asked?
For what it's worth, I didn't get that last part that you were just discussing. I mean, maybe it's not. We don't have to cater to me on this, but hey, I can kind of plumb in any sort of source table.
Yeah, I mean,
like,
right.
What is that? What do I actually need to handle? I mean, read Parquet, get Kafka. These things kind of make sense to me, and things kind of magically work. Oh, get Kafka stream table. Okay. Kafka has a thing. We've mapped a stream table interface to that. I understood that as of Friday, right? But
yeah, so,
imagine, I don't know. Imagine you have transactions that are changing a source table.
Yeah. So
you're saying I think that a user could plumb those two together. I don't think it would be very easy for them to do it, is my guess.
Well, the source table is just a root of the DAG, and really specifically, we should call it a live table. So Parquet is a source table, but it's not in the DAG. So, right, there's no reliance on it doing anything except providing an index of rows that exist and then data for those rows, right? Like table tools, new table, right? It's not a source table, it's not in the DAG, but it has to provide an index and it has to provide the data that the users actually want to see. Something like the timetable, which is a source table, it's append only, so it never frees anything. But you could imagine a different version of timetable that automatically does a last by, right? So that you don't add a row every second forever. So it can just rewrite right in place over its data. You know, and that's basically what Kafka does. And the live tables have a callback that's refresh, and that's it. And it is up to them to look at the outside world, however they do that, and decide whether or not to create an update. And their updates follow the same model as a derived table: added rows, removed rows, modified rows, or shifted rows. So if you're a user and you're creating a new source table that's ticking, you need to understand the update model enough to tell the downstream operations when things have been added, modified, or removed.
Okay. Well, for what it's worth, I think, so I've always thought, I think that there's sort of 3 white papers that come from this, right? I've always thought that there's 2. One is the update model. Hey, data's in a state of flux. That means to us, add, remove, modify, and shift. And, here's why that's important. And that's the end of the paper. The second is, hope you read the first paper. If you've absorbed those concepts, you can understand how all these downstream operations can be much more efficient than if you're doing them without that knowledge, in batch mode or micro batching mode and stuff like that. I've always thought those are the first 2, but really the first white paper that might be interesting is when we say table, we really mean live table. And here's the 4, 5, 10 types of live tables we think that naturally exist in the universe. Right? And they have names, and stream table, Kafka happens to call it this. Timetable is an example of append only table that everyone uses in this thing that way. Right? So the idea of live table, that's vernacular I've never used that I think is very powerful, but understanding here are the 4 or 5 fundamental flavors of live table that resonate with people's intuition is pretty powerful stuff to put out front of on our quote unquote cover page about why we exist. Tables aren't tables, they're live tables. They come in these 5 flavors. Just reading that, they exist. We are speaking the truth, and nobody supports them.
Yeah. So, Mike, you were interested in the subject. Do you have any questions?
I think I'm okay. I'm sort of in a trance trying to visualize everything that we're describing. A drawing would sure have helped. But I think I've got what's going on.
Right. Charles, what else should we have asked about?
Yeah, Mike is right that whenever I do this, I usually draw this on the whiteboard, but I don't know that the whiteboard has ever been captured showing the table and the column sources and the index with those initial examples.
So if it would help, in the bottom right-hand corner, if you click on the triangle pyramid-looking thing, there's a whiteboard option on the bottom.
Yeah, I think at this point it's probably not.
Yeah.
It would make more sense just to draw it on a piece of paper and send a picture.
Right. Amanda, JJ, anything else? Good.
But I'm not wrong here, Charles, in saying that this one is maybe not one to understand all of the details about how this works, but I think the DevRel team needs to really internalize that this is different and this is important.
Yeah, if it's not important, then
go use something else.
Yeah. So I think it's important for a few reasons. One is it's important because it's a key piece of our intellectual property and what differentiates what we're doing from what other people are doing. It's also important in the sense that we need to be able to clearly describe these concepts so other people can make their own custom data sources and custom operations.
Yeah, but most fundamentally, I think if we can figure out how to talk about this is where it comes home with me. Is all the time I try and talk about our differentiators. All the time, our leading differentiator revolves around this. The language I invariably have to use around that relates to real-time data. Okay. And then I'm like, I know that's crappy. I don't like that. Because as soon as you say real time and you tell people you're from Wall Street, they think, well, nobody cares about the latencies that Wall Street cares about. And they're right. Right. So now it's like, oh, we've been relegated to a small corner of the world. So then I say, well, it's really dynamic data. The data is in a state of flux. And therefore you need this infrastructure because you want your architecture to appreciate that reality and to best serve the fact that your data is in flux. When I say that, that feels like something, feels like I flirted with a nerve, but it doesn't feel like I banged the nerve. It doesn't feel like when I say that, people are like, oh, heck yeah, you just told me some serious ass truth because data is in the state of flux. They believe that, but then you're like, whatever. Everybody else, Spark's worth $30 billion and their leading headline is streaming analytics. Kafka is the king of, of real-time events, right? So Pete, thanks. You're right about dynamic data, but you're lying about you being unique. There may be language around this that is the best way into the front door around, different source data types and bringing them all together and doing this stuff in the background that is really important and makes it all super efficient. But your group, the group on the phone, is going to be better about figuring out how to tell that story than I am because you're the target audience, not people like me.
Yeah, I guess, having heard this for the first time, what are things that jump out at y'all?
So I guess one of the things that I'm struggling with is the use of the word index. To me, like an index takes a key and gives me some value from that key, and maybe that value is just like a location, right, of the record, the rest of the record that I want to see.
Yeah,
but I'm not sure you're using index in the way that I'm.
We're not. It's a bitmap, and that's literally all you need to think about it. It's a bitmap. It provides, your basic set theoretic operations like intersect, insert, subtraction, union, all those kinds of things. Iteration in terms of ranges and the ability to retrieve a particular position, which is, what the hell is it called? We call it get, but it's, is it rank? No, it's not rank. Rank is find. It's, shit. There is an actual name for it. Not rank, because rank would tell you. All right, sorry. Now, So it's getting index 4 rank.
So that if I have it right, I mean, that bitmap is just giving you the presence or absence of what columns are available in that particular point in the
what rows. What rows. Columns are always available. So
it's got to be a pretty big bitmap, right?
Yeah, I mean, it will. They get big.
Okay.
It's the performance of that is critical to the performance of the system. So if you have a billion row table, there's necessarily a billion entries in that bitmap, and there's about 4 different implementations of the bitmap. There's a single range, like 0 to a billion. There's 1 value or 2 values that pack deeply into an object. There's a version of that which is a list of sorted ranges. If you have less than, I think, 1,000 of them, that scales with the range of the values. That if you have things that fit into ints, you can allow more values than if they only fit into longs, and still use the same number of cache lines. And then we have the full up bitmap that is blocks of 2 to the 16 bitmaps with a locator entry that says where in the key space that is. And that bitmap is either, there's a thing called roaring bitmap. So it's either a roaring bitmap, which can in turn be an array container, a bitmap container. So that's the only time it's an actual bitmap, or a list of runs. Or it can say everything in this 2 to the 16 span plus more is set, or it can say exactly 1 thing is set. Trying to most effectively use that memory.
Mike, any other thoughts?
That helps, especially now that I'm looking at rows instead of columns. But yeah, it might take a couple iterations to really grok what's happening.
Yeah, so Christian is king of indexes.
Yeah, I was thinking of asking him to talk next, just since we're on the topic. All right, JJ, what are your thoughts?
Well, I don't. I mean, a lot of this terminology is fairly new to me, just in general. So it's a lot of new concepts that's going to take a while to process. I mean, it's all really interesting stuff that gives me a much better understanding of what's going on underneath the covers when I do things. Especially since I've been working, with some of these column sources and a lot of these updates and these methods that are calling this stuff on the back end. I don't have any specific questions because I think I came in with pretty minimal knowledge to begin with, so there's just it's a lot of information to process.
Let me provide something. Let me ask Charles a question. Charles, what percentage of our users, or let's pretend we had 1,000 users that were 1,000 developer users, not just dashboard guys, or query users at least. How many of them would understand as much as half this group understands right now? How many of our current, if you said take our current user base and turn them into 1,000 people, is it less than 100? Less than 10% know anything about this stuff, or is it less than 1%?
No, it's probably about 20.
20%. Okay.
So
yeah, I mean, some of these concepts come in if you have to do performance tuning and things like that.
Yeah, so just thinking of our current users, developer users, right? Like, Andy doesn't count, but Rafi knows about indexes. Our users know about them because they show up in assertions, unfortunately, because someone can't write a query engine that works right. But like Peter or Yo write listeners and need to iterate these things and retrieve values using them.
Okay.
So that's, and
I do think this stuff hits performance, but I think oftentimes when it hits performance, people learn rules about why things were bad, and then they follow those rules rather than understanding exactly what happened at the index level.
Yeah, like I don't think anyone at Streetcar knows that.
Yeah.
Galileo is half our employees. They have 2 real developers who are doing stuff on their own. I don't know how much they would actually know this. Maybe a little bit, but
we can move on. I just don't want JJ and others to feel constrained at all before they master this, and 2 feel like they can't communicate with users because many users in many use cases will be entirely oblivious of all this sausage making.
Yeah, users probably never write a source table. They will care about listeners to interface with their other system. That they would like to send data to Solace or update a cache of positions that they use for short marking in their REST server or whatever. So they'll care about that, but they're not going to then assemble their own downstream update in 90% of cases, probably.
Yeah. So, I mean, a lot of what we're going to have to teach people how to do is to write kind of leaf nodes.
What does that mean?
That means like you have your DAG, which is your query. Most people are not going to write anything at this level that deals with updates, but the people that do, most of them will write things that attach at the end of the DAG, so that it sends data to another system or something like that, rather than something in the middle. So, Amanda, what are your thoughts?
Looking at him like a DAG has really helped me a lot in processing these and where we are in the refresh cycle and whatnot. I'm thinking, I'm a very visual person, so just when Charles was talking, going back to that DAG and trying to think where we are in that for the updates has been really kind of how I've been thinking about it.
Okay.
Charles, I have written some functions at the user level that involve a .get method, and this is the first that I've heard that there are alternatives. Get chunk.
Yep.
So what does that mean exactly? I maybe I misunderstood the get chunk, or I just kind of missed it.
So,
or maybe you didn't cover it as much.
What is that? I haven't covered it, but get chunk is get. You pass it a key, right? That has to be valid from your index.
Yeah.
Right. So there's data columns which are even worse because they're positional. So they're this, index get operation followed by a column source get. So whatever you do, don't use get column, use get column source to get a column source. And then from that, the ideal way to read is to call get chunk or fill chunk. And those take a ordered keys, which is a subset of an index. Jetty rest.
Yeah, so we should certainly look at that in here.
I have a well-commented example on the enterprise side.
Could you send that to Alex?
I think this will matter a lot to you, Alex.
Yeah.
Actually,
I mean, it should matter for anyone who wants to read data.
Yeah, but yeah, as I understand, his implementation is pretty much reading data and doing a transformation for PyTorch.
Yeah, so you should be able to share that with others. It also includes things like concurrent data reading and whatnot, which you don't necessarily need, but it does have get chunk and shared context and iterating in ordered keys. You iterate it in groups of keys, not in one key at a time.
Right. Yeah, and that could actually simplify the gather stuff that the user has to write.
Yeah.
If they don't have to iterate.
Oh, I don't know about simplify, but it could make it faster.
Yes, faster. Not simplify, but faster.
Yeah, so this would be like in the functions we provide. Yeah.
All right. I have to drop off.